Hey guys, welcome back. So what we're looking at today is Unit 5, Lesson 8, Linear Functions. So let's go ahead and jump right in. So Jada earned $7 per hour mowing her neighbor's lawns. Name the two quantities in this situation that are in a functional relationship. Which did you choose to be the independent variable? What is the variable it depends on? So our two variables based on this are going to be time and money earned. So time and money earned. So which is going to be the dependent variable? So the dependent is going to be the time. So this is going to be dependent. Oops, wrong one. Got flipped around in my brain. Time is going to be the independent, and money earned will be the dependent because it'll depend on the time. So write an equation that represents this function. So money equals 7t because we're taking 7 times the time. So here's a graph of the function. Label the axes and label at least 2 points with input-output pairs. So our money is our dependent, and the x-axis is our dependent axis. So this is money, and this is time. And so we could have a point here. Let's say it's 7, 1. And then we could also have 14, 2. So there are a couple points, and that's just plugging in the value, some value of time to get a monetary amount. Okay. All right, convert feet to yards. To convert feet to yards, you multiply the number of feet by 1/3. Name two quantities in this situation that are in a functional relationship. Which did you choose to be independent variable? What is the variable that depends on it? So the value of a measurement in yards is a functional relationship with the value of that same measurement in feet. We can choose to think of y as a function of f or vice versa. So it works both ways for this. So either can be independent or dependent. It just depends on how you choose. And so our variables are feet and yards. So write an equation to represent it. So we could have feet equals 3 times y, or y equals f divided by 7. Not 7. Okay. So our yards would equal f divided by 3. There we go. All right. Draw the function of the graph, label at least 2 points with input and output. So I'm going to do length feet, and this one will be my yards. So if we plug in a value for yards, so let's say 1 yard would give us 3 feet. So we'd have a 0.31. No, it's proportional, something like that. If we do 2 yards, 2 times 3 is 6. So we'd have 6, 2, and so on and so forth. And you can use either or. So we could have done feet and started dividing to find these values as well. Okay, so all these relationships are, both of the ones we looked at were proportional relationships because they both had that point at the origin. So they were both proportional relationships. And they were also linear because they represented a line. They formed a line with their solution. So linear is your key word for this lesson, linear. All right, which is growing faster? Noah is depositing money from his account every week to save money. The graph shows. So Noah is depositing money in his account every week to save money. The graph shows the amount he has saved as a function of time since he opened his account. Elena opened an account the same day as Noah. The amount of money E in her account is given by the function E equals 8W plus 60, where W is the number of weeks since the account was opened. So who started out with more money in their account? So looking at Noah's, we can see on the y-axis he's at 60, and then after 2 weeks he's up at 70, another 2 weeks he's at 80, so on and so forth. So he looks to be going up by $5 each day each week, since every 2 weeks he's going up 10, half of that would be 5. Elena is, her y-intercept would also be 60. So that means that they started out with the same amount. So the y-intercept looking at the graph, and the y-intercept looking at the equation. Now for 2, who is saving money at a faster rate? How do you know? So like I said, Noah is going up every 2 weeks, he's going up $10. So if we plug in a 2 into Elena's, 2 times 8 would be 16, plus 60 would be 76. So she's going to have more money because, like I said, 10 divided by 2 is 5. So that's his rate. 5 is what he's going up each week, whereas Elena has a slope of 8. So Elena is saving money at a faster rate. All right. How much will Noah save over the course of a year if he does not make any withdrawals? How long will it take Elena to save that much? So first we have to think about how many weeks there are in a year. There are 52 weeks in a year. So if he started at 60 plus 5 times 52, so 52 times 5 is going to give us 260 plus his initial 60, which would be $320 total. Now Elena had the equation 8w plus 60, so we'd plug in 52 for 8, so 8 times 52 plus 60. 8 times 52 is 416 plus 60, which would be 476. So Elena is definitely going to save more money than Noah will. And for Elena to save the 320, well, we take 320 and set it equal to 8w plus 60, and then we can solve. So subtract the 60. I don't know why it's doing the random weird lines again. So 320 minus 60 is going to give us 260 equals 8w. Divide by 8. So we divide 260 by 8, and we're going to get 32.5. That's supposed to be a 5. So 32 and a half weeks is how long it will take Elena to save the same amount as Noah did in a whole entire year. So it won't take her a full year to save as much as Noah will. All right. If you guys have any questions, feel free to ask. Have a great day. Your keyword is linear. Linear. All right.